What the hell are you doing?
Container fight. Did you know that you can now run containers natively on macOS? Same on Windows. Maybe. I say maybe because it has to do with what your definition of containers is. And when I've stated this opinion, in the past, people have gotten upset and I've received some criticism about what the definition of a container is. So today, I want to talk about macOS containers that run natively on the host operating system, Windows server containers, containers in general, and also people reacting to a previous video I made about change root, about chroot, making container implementation on top of old school Unix syscalls, and why people objected to that and object to macOS containers even being containers. That's the talk. This is where we start, right? I made a video where I showed how you can use the change root, the chroot call that's been in Unix since forever to run Docker containers from Docker Hub. I got feedback on a forum, and I'm not going to say the person's name. They're an intelligent, smart person. They know a lot about virtualization. They told me I was wrong, and I disagree, right? They said, the problem with a lot of your article is that you are conflating shared kernel virtualization with containers. Those are different things. I'm gonna get into what their point is, but now Mac containers are out. They use my trick. Mac containers use change root to implement a container interface that runs natively on Macs. So I don't know. Here's why I think I'm right. But first, like a quick rewind through my previous talk, right? Containers are a thing, a container image is a package, and then you run it on a machine. And there's lots of different runtimes that can run them, right? Some are very small, like run C. Some are full VMs, like Firecracker or Kata containers. But what I showed in a previous talk was like, you can build your own container runtime if you just use change root, and you'll be able to, it's like 20 lines of code, maybe even less. You'll be able to do something like this, right? I say chrun Redis, I start up a Redis server. And then I could do it, open up another terminal, and then connect to it and start poking and pushing values into it. Seems a lot like a container, right? You're even running the container images from Docker Hub. The way it works, obviously, is change root. So we extract the file system of a Docker image into a temp directory, and then we just start a new process up inside there using change root so that that's all they see, right? And doing this, I don't know, it's cool because it shows you that on Linux, people say a container is kind of like a lightweight VM, but really what it is it's a process, right? A process that has been given its own view so that it looks like it's all by itself, but it's not really, right? And it has some constraints on it, like it's running on a machine that only allows so much memory, but really it's not, right? These are constraints you're applying on top. You can do that first part, the file system isolation part, to a certain extent, just using this change root system call. This was my talk. I showed how it's done. And then I showed there's other stuff that you can add after that. We'll get to the controversy soon, right? Like my implementation doesn't have namespaces. Namespaces are what make it when you are inside a container, you're not able to see the other processes of other containers or things running on the host, right? They're what let you control all of this. They're what let you have like a PID1 process running inside a container when there's a PID1 process somewhere else, or have a different user or have a different host name. Also, C groups, right? So C groups are control groups, and these let you isolate. No, isolate is the wrong word. Restrict, control for control group. What that process can do, what the memory limits are, what the CPU limits are, what the prioritization of it is. Doing things like this here, Docker run memory, and we're just giving it 10 megabytes. Also, I just use change root, this old school command, but pivot root is a more modern implementation that's safer because you can escape from change roots. Anyways, you should check out the talk. I don't want to go all through it, but the cool thing is it's in every Unix system, including, if you follow this chain, Mac OS X, right? What I'm running right here. And that means that we can take this idea of native Linux containers, maybe we can bring it to a Mac. Maybe we can use this syscall to give us something like a container, right? And obviously, it's not going to be exactly the same as the Linux implementation. It won't have namespaces. It won't have control groups. Those things don't exist, but it will be native. And bingo bango, now there exists an initiative. Mac OS Containers is very early days, but it is a container implementation that uses change root on Mac OS X. And so I want to walk you through it, but first of all, I want to talk about the definition of containers, because people even in this new release get upset in the same way that my person up here did, saying like, these are not containers, right? The main use case for Docker on Mac OS is to provide a development environment for people to deploy things on Linux. Why would you ever want a Mac OS native thing? And also, if you're going to provide isolation, use a Mac OS sandbox framework, because just using change root doesn't give you the isolation that you need. All that's true. But I still think this is super useful, and I think that we can call this containers. I feel a little bit exercised, but let me show you, okay? So containers traditionally on Linux look like this, right? You have the kernel, and then you start up these containers, and using the tricks we just talked about, the container process looks like it's by itself, to itself, right? And the way that it does that is with those syscalls, and that is, in a purist sense, what a container is. Just this, right? So you have these things, a C group, a namespace, a pivot root, and a Docker runtime is just something that uses all those things to make this, right? That is a purist definition of containers. But of course, that got extended, right? Because people on Windows are running Linux containers, and the way they're doing it, let's go to my better drawing here. The way they're doing it is like this. They're running a Linux VM, right? And inside that, they're running the Linux containers, right? So it shares the kernel with the other containers inside the Linux system, but it's not the same as the host, right? And Docker Desktop kind of magics this all away, so you don't really notice this box. You're just like, oh, I have Linux things running, and you know, there's not a lot of overhead to them. Same thing happens on Mac, right? You have this Linux box that's a little bit hidden, that's, you know, runs pretty well due to all the work that they put into this virtualization layer. And yeah, the kernel's shared here, but not with the host, right? They're not native. And there are downsides to this. Like, the huge upside is you're deploying things into production on Linux servers, and now you can run Linux containers on Windows, on Mac, and they're going to work the same way they work in production. It's a huge benefit, right? But some downsides, right? It's not very useful if you have things that you need to do on a Mac, right? If you need to do a OS X build, if you need to do an iOS build, if you need to do Xcode stuff, like none of this you're going to be able to do inside here. You're not going to be able to containerize your Swift build process using this system. So enter on Windows Server Containers. Windows has more than one container implementation. There's one that uses Hyper-V, and in which case it's actually more like a virtual machine. But Windows Server Containers run on Windows, and they share the kernel. They use something called silos to do the isolation, and some sort of network filtering. They use a couple of Windows-specific operating system technologies to build what they call Windows Server Containers. The question, the debate, the controversy that I keep running up against, or people telling me I'm wrong, is this a container, right? This doesn't use any of these things, right? So how can it be a container? Well, I think that we have expanded the definition of container, and we just need to come to terms with that. If you're running Linux containers on Linux, there's no VM. On Mac or Windows, there is a VM. But more importantly, right, in a purist definition of Linux containers, a container has to use C groups, namespaces, pivot root, etc. But in this expanded definition, I'm calling expanded definition of containers, a native container is just a shared kernel isolation mechanism, right? And the way that it's implemented doesn't need to be these Linux syscalls. I mean, it can't be, right? It just definitionally, it can't be. Instead, each OS will have its own implementation of how you have this shared kernel isolation mechanism, right? So on Windows, it's silos and etc. On Mac, it seems like it might be using change root, at least in this one implementation. So this is what I say. We need to expand the definition. When we talk about containers, we're not just talking about these things. We're talking about a more expansive definition, right? We're not just talking about this and this. but we're also talking about this and this. I don't know what else to say. That's my big point. Now, with that point given, I think we can now talk about why Mac OS containers are useful and how to use them and how early they are, right? I think this diagram also serves to highlight that a Mac OS native container, the useful thing about it is to do Mac OS X development, right? Or to do Mac native things, because you're no longer mirroring some production Linux server, right? You're doing things natively. Let's go through that, right? So the project has just been announced. The developer of Mac OS containers is Sloanopotamus. Great name, hard for me to say. Dig it though. And his main use case, he said, is Xcode builds to do things in CI. The reason that I'm excited about this is sort of the same reason, right? Earthly, you can see we're on the Earthly website right here. Earthly does building software, right? And we do ARM builds and x86 builds, and we have these satellites, and we have people who, they do Mac builds. They need to build an iOS app or something like that. We'd love to be able to offer Mac native containerized build capabilities, but to do that, we need something like this effort. This effort is a bit early for us to actually use, but let me get into that, right? To use Mac OS containers, the first thing that you need to do is disable the Mac system integrity protection, which is not to be done lightly. Like you have to restart the computer, into safe mode or recovery mode. You need to open the terminal, turn it off, and when you have it turned off, it's kind of a secure boot functionality that stops the computer from starting if the OS has been modified. So with it turned off, you could get persistent malware, right? Something could get on your machine, modify something, and be there all the time. That'd be bad. Anyways, disable it if you want to use these containers, which I did. You can enable it later. Then you can install Mac containers using Brew. A cool thing about Mac OS containers is to get them working, Sloanopotamus needed to patch containerd and dockerd and buildkit to add in support for the Darwin operating system. It's awesome that he went and did that. Those changes have not been upstreamed yet. So to use this, you cannot run Docker Desktop because it will have its own versions of these and they'll conflict and it just won't work. So you need to stop Docker Desktop. Use Brew to start up his patched versions. Oh yeah, and this is some of his patches. If you just go and look at the commits, yeah, he's done a lot of work to get especially the fuse mount working. So we start our own version and then we can do a Docker run and start up Mac OS containers. Let me just show you how this works, right? First of all, you need to start with his base image because if you recall, the way a container is working here, it needs to move you into a root where you can't see the host file system, right? But in that, because you're sharing the running operating system, you need all the user space operating system libraries and stuff in place. So Sloanopotamus has built up these images, base images that contain the Mac OS, user space that's required. Let me show you here. You'll find them on GitHub, and there's one for each version, and they're gigantic. Like this is like, I think like 7 gigs or something. If I do, what do I do? Docker image ls. There we go, 7.3 gigs for my simple image here. But once you have that, a lot of things work really nice. So this is my Docker file. I'm going to start with that, and I can just build it in the standard way. I put together some functions to save on the typing. So I can just do like build simple. And you'll see right away that we might run into some challenges. Let's see how it goes. Oh, it worked. Excellent. Okay, once we've built that image, then we can just run it, right? Run simple. Now I'm inside of a containerized Mac OS, right? You can see present working directory. I'm in home user. Who am I, right? I'm root. What's in my home? Nothing much. I can go up here. Tree. Can't run tree. It's not on there. Oh, yeah. And we can also look at who I am, right? So you can see it's a Darwin system. And If we do this, we see this is my machine, right? Same as here. If we were on Linux and we popped into a container, this uname wouldn't match because we would be using namespaces to give a different host name. But here, because we're just using change root, there is, limited isolation. Same like if we go look at the processes, there's nothing. But even inside the container, when we do PSE, we can see everything, right? Not just other containers that might be running, but things on the host, and we could kill those as well. So there's not a security barrier here, but we do get the type of isolation that would be super useful for, say, building things. So this is macOS containers. I think it's pretty cool. I did run into problems. It's still very early days, right? If I want to copy in some files, for instance, let's exit out of this. Let's build this. We can see, just even the copy command does not work. We get this cross-device link. I looked this up. This is like a Go error, something to do with how the partition mounts, I believe. Luckily, there is also an add command that Docker has. Look at that. That also does not work. So it's early days, right? If you want to get files in, you have to do it some other way. You could curl them in from some remote place. You can see I was running something that needed password file and group names, and so I tried to create those. But yes, this is macOS containers. I think it's pretty cool. Lots of things, though, I have to warn you, do not work. I can't run Linux containers and macOS containers at the same time, which makes sense, but was a little disappointing to me because I was kind of imagining that, like, oh, I have my Linux VM and I have my Linux stuff in there, but then I can also run like native stuff. Maybe I can put them all in Docker Compose and start them all up. We're a long ways from that. However, right, there are PRs to upstream these changes into BuildKit and related areas. So maybe once that happens, that will be easier. Also, as mentioned, copy does not work. Seems pretty important, but it's not there yet. Can't install Xcode, right? So one of the big reasons you might want to use this is you want to do a containerized build, right? You want to build something for Macs. You're going to need Xcode, but still pending, right? If you try, you can see Slonopotamus has been trying to put this together, but is getting pretty close. I expect this to soon be solved, right? Maybe by the time this video is out. Right now, though, Xcode can't do it. Can't use this with Earthly. To get this all to work, these changes need to be upstreamed into BuildKit, and then Earthly we have our own fork of BuildKit. We pull that down, and then maybe we could set up macOS satellites, run this Mac version of BuildKit on there, with these changes upstream, and then you could push builds to it, and it would be awesome. None of that's possible right now. But I think this is a super cool project, right? So get involved, check it out. You can follow these links to try it out. A lot of the important issues that they're working on are on the RunD project. RunD being the Slonopotamus's fork of RunC that uses change root as the implementation. So it's kind of a shim to get things to work on Macs, and you can see the various problems being worked on here. Interesting thing to me, to bring this back full circle to the controversy. So this came out, people got excited, it showed up on Hacker News, I assume because people were excited, but then lots of other people were like, I don't get it, who cares, etc. Right? And one of the big questions was, hey, how can this be a thing, right? Containers are about namespaces and using a bunch of OS interfaces to isolate things. We can't do that on a Mac, right? This goes back to my original thing. Listen, we need to think of containers in a wider sense. If we're going to be talking about containers running natively on Windows, on Macs, etc., we need to expand the definition, right? What if there was a way to run containers on BSD and it uses BSD jail? Can we call that a container? I say yes. Let's expand the definition of what containers are. They're not just something that runs on Linux using Linux system calls or in a Linux VM on some other host machine. They are a way to do shared kernel isolation. That's what I say, right? That's why I put together this nice little table here. Expanded definition of containers, a generic shared kernel isolation mechanism. It's gonna have to work differently on each host operating system, right? It's going to have to work differently. On Windows, you can't call Linux syscalls. On Windows, neither can you on Mac. So we're expanding the definition. Also, right, if you like this video, if you're interested in containerization, you should take a look at Earthly. That's who I work for. And we make building things faster using containers, and easier and more reproducible, because containerization helps make things reproducible. Yeah, so that's it. Let me know what you think, and take care.